Bismillahirrahmanirrahim. Electrical network analysis. So, in the previous section of this lecture, we have started the Laplace transformation. Okay, and we have studied the Laplace transformation on RL circuit, and then on RC circuit, and then on RLC circuit series. Okay, series RL, series RC, and series RLC circuit, and followed by the two cases. Case 1, that is the undamped case or loss free circuit, and case 2, we have studied the case 2, that is the underdamped. So in this lecture we will study the remaining two cases, that is the overdamped and critically damped. So let's start. For example, this I of s is given 1 over s square plus uh, 1 s, sorry, 18s plus 81. By comparing it with the general equation, that is s square plus r over l s plus 1 over l c is equal to 0. So the denominator of this given equation is s square plus 18s plus 81. So s square r over l is equal to 18. Okay, r over l is equal to 18. So assuming l is equal to 1, so by this you will get l is equal to 1. Okay, r is equal to how much? 18. Now 1 over c over l is 81. So c over l is equal to 81. As we have assumed l is equal to 1, so c will be 81. C 1 over 81. Okay, 1 over lc. This is actually not c by l, but 1 over lc. So by this way, c will be equal to 1 over 81. Okay, so putting the values, you will get this. I of s is equal to 1 over s square. Okay, this was the given equation. Taking s common, so by factorization, you can find the roots by factorization, and also by uh, factorization and by quadratic formula as well. So by factorization, s is equal to minus 9. Okay, and minus 9. Uh, Same, identical, real. Okay, if you find it by the quadratic equation, you will get the same answer. So minus b plus minus b square minus 4ac. Okay, c is 81. So 81, this is plus my b square, this is 18 square. Okay, not the 81, 18 square minus 4ac. So from this you will also get s is equal to minus 9, and s is equal to minus 9. Okay, so the general equation is y of t is equal to a plus b t into e to the power lambda t for the overdamped case. Okay, 1 over s plus 9 into s plus 9. Okay, so taking the Laplace and inverse Laplace of these terms, so you will get e to the power minus t into e to the power minus 90. The bases are same, their power will be added, e to the power minus 18t. The waveform will be just like this. Okay, so the nature of the roots in the case A, which was the undamped case, so the nature of the roots were pure imaginary. In case 2, which is the underdamped case, the nature of the roots are conjugate complex, that is a plus jb and a minus jb. The real will be same, but there will be opposite sign for the imaginary term. That is called the conjugate complex. Okay. So case 3, overdamped, pure, real and unequal. And case 4, critically damped, and the name is critically damped, and the nature of the roots were real and equal. Okay. So in paper you may be asked to find H, okay, the circuit, the which case, okay, case name, waveform, you have to draw the waveform, values, you have to find the values of RLC, okay, and transfer function. So now the third case we have discussed case 1, 2 and 4. Now the third case is overtime. So now again the given equation is 1 over s square plus 5s plus 6. So again we have to compare the denominator of this given equation with the general equation, that is the s square plus r over l of s plus 1 over lc. Okay, so s square, now r by l is 5 and 1 over lc is 6. Okay, so again assuming l is equal to 1, okay, in order to find the r and c values, so let l is equal to 1. So putting l is equal to 1 over here, you will get r is equal to 5. Okay, and by putting l is equal to 1 over here, so you will get c is equal to 1 over 6. Okay, so now r is equal to 6, l is equal to 1, c is equal to 1 over 6. I of s is equal to 1 over s square plus 5s plus 6. Okay, so the roots again by factorization you can find it by the quadratic formula as well. So 1 over s into s plus 3 plus 2 into s plus 3. Okay, so s plus 3 into s plus 2, these are the factors. Okay, so the roots are s is equal to minus 3, s is equal to minus 2. So the general equation will be y of t is equal to a e raised to power lambda 1 t plus b e raised to power lambda 2t. So lambda 1 is minus 3, lambda 2 is minus 2. And the nature of the roots are real, both are real and unequal, means distinct, real and distinct. The transfer function, now the transfer function I of s is equal to 1 over s plus 3 into s plus 2. So for the transfer function you have to find the it by the partial fraction. Okay, a by s plus 3 plus b divided by s plus 2. Okay, so the LCM is s plus 3 into s plus 2, multiplying this LCM on both side of the equality equation. So when we multiply this LCM over here, so you will get 1, because this will be cancelled out. And when multiply with this, you will left with s plus 2, and for b s plus 3. In order to find a, you have to make b term 0, and if whenever you want to find b, you have to make it 0. Okay, so now first of all, a, in order to find a, s if we put s is equal to minus 3 over here, so you can see that b term will be 0, so you will easily find the a value. So put s is equal to minus 3 in this equation. So a is equal to minus 1. Now in order to find the b, put s is equal to minus 2. So you will get the a will be a will be 0 and b will be how much, 1. Okay, so now putting these a and b values in this equation. Okay, so you will get I of is equal to minus 1 over s plus 3 plus 1 over s plus 2. Taking the inverse Laplace, now it is easy. So minus e raised to the power 3t minus 3t. Okay, because if this is plus, so this must be minus. Okay, because the e raised to the power minus 80. The Laplace of e raised to the power minus 80 is how much? 1 over s plus a. So by this relation, we can say that if there is if the a is minus, then in the Laplace transform, this must be plus. Okay, because these two are signs are opposite. So if this is plus, so this must be minus. Okay, and again if this is plus, so this must be minus. Okay, so here we have I of t. Okay, so the waveform for the overdamped is just like this. Okay, so here is the assignment for you people. The assignment is, this is the circuit, and for this circuit you have to uh, draw the circuit diagram, mention the case according to the nature of the roots, and find I of t and draw waveform. I of s is equal to 1 over s square plus 3s plus 2. I of s is equal to s plus 2 whole square. I of s is equal to 1 over s square plus 2s plus 4. These are the questions. Okay, these three are the questions, and for all of these three questions you have to find, you have to draw the circuit diagram, mention the case, okay, nature of the roots, and find I of t using the Laplace transformation, and draw the waveform for the corresponding case. Okay, if this is the case of the underdamped, so you have to find the, you have to draw the waveform for the underdamped, and if it is critically damped or undamped or overdamped, so you have to draw the waveform for their respective cases. Okay, okay, the general equation, generalized equation for all of these cases will be y of t is equal to a e raised to the power lambda 1 t plus e raised b e raised to the power lambda 2 t. For underdamped, it is the same just as above. In the overdamped, okay, the generalized equation is same, but in this we have, you can see bt e raised to the power lambda t. Okay, because in this case the roots are equal, so there is no need to write lambda 1 and lambda 2, because both are equal, so no need to write lambda 1 and lambda 2, just write lambda lambda. But here from the solution you can see that y of t is equal to a e raised to the power lambda t plus b t e raised to the power lambda t. Okay, where lambda are the roots. So the only difference is here, because the roots are equal. Okay, so that was all about the Laplace transformation. So we have wound up the Laplace transformation chapter, and in the next lecture we will study the Fourier transformation. Okay, so a little bit introductory words for the Fourier transformation, so that it may be easy for you while you will study it. Okay, so Fourier transformation. Okay, in the Fourier transformation, if this f of t is the function, okay, so in the Laplace transformation, it was converted to the S domain. But in the Fourier transformation, the time the t is converted to the omega domain, or we can say that the frequency domain. Okay, omega is equal to the angular frequency. So sorry, this is not the Laplace, but the Fourier. Okay, so Fourier transformation can be represented by this stylish f. The Laplace transformation is denoted by the stylish L, and in this case, it is represented by the stylish F. Okay, so the only difference is this: all the rest of the solutions are same. For example, if the Laplace transformation of e raised to the power minus at is 1 over s plus a, okay, so in Fourier transformation, it will be e raised to the power minus at. Okay, the Laplace transform. This is the Laplace transformation, and now this is the Fourier transformation. Okay, so Fourier transformation will be 1 over omega j omega plus a. Okay, j omega plus a. So only difference is that. So the Fourier transformation is more or less same as the Laplace transformation. So if once you have understand the Laplace transformation, then it will be easy for you to understand the Fourier transformation. Okay, so I suggest you to have practice on Laplace transformation, so that it will be easy for you to solve the Fourier transformation, and also do your example, the assignment as well. Okay, so thank you.